All right, today we are working in page 375 out of your first workbook, and today we're going to be dealing or working with how to make predictions. Now, we have a lot of vocabulary happening in this lesson, so it's very important that you pay attention as we discuss it, and that if you have any questions that you ask them in class or online when you get a chance the next day. So today our question is, how can I analyze relationships to make predictions for probability experiments? In a board game, you get an extra turn if you roll doubles or two of the same number. That's what doubles means. How likely is it that you will roll doubles? You can conduct an experiment to determine the relative frequency of rolling doubles using two number cubes. Relative frequency is our first word. It is the ratio, which means it's like a fraction. It'll be written as a fraction. It'll be something over something else, so it'll be something like one number over something else. It is the ratio of the number of experimental successes to the number of attempts. So it's how many times you were successful at doing whatever it is you want over how many total times you did the experiment. That's how you write your ratio. And you will be practicing that today as we go on through this lesson. So let's continue to move through and we move the page up. Let me clear the screen out really quick because this is not traveling with me. And then we'll continue. So, hands-on activity number 1. Complete the table to show the sample space for rolling two number cubes. A sample space is a list of all the possible outcomes you can get. In this case, the event we're going to do is roll two number cubes or a pair of dice. Shade all of the possible outcomes that are doubles. The probability of rolling doubles is blank. So first thing we need to do is complete the table. What they have here are the numbers. For example, when they rolled the pair of dice, they got two ones, or snake eyes. Here they got a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, and 1 and a 6. Or you can roll a 2 and get a 1, or a 2 and a 2, or a 2 and a 3. And you can continue filling out this chart totally. 2, 4, 2, 5. You can roll a 2 and a 6, and then fill out every combination on this chart that there is. Next thing you're going to do is you're going to shade all of the possible outcomes that are doubles. That's where you have the same number twice. All right, so for example, we already have an example of that right here. We have 1 and 1. That's a double, so I can kind of shade that in. I want to see the number, so I'll leave it there. We also have 2, 2. We can roll double 2s. We can roll double 1s. And there are different combinations you can roll that are doubles also. As you do your chart, you will fill in anywhere that there's doubles by shading it. Please shade around the number so you can still see the doubles. After you've done this part, you have a question that's being asked. Our question is, how many times would you expect doubles to be rolled if you roll the number cubes 50 times? Explain your answer. And that's something you're going to be working on with your partner or by yourself, depending on how you're grouped. Going on. Now we have step 2. Now you guys are going to roll two number cubes and record the number of doubles in the table. Repeat the experiment 50 times. If you're by yourself or working alone for whatever reason, then go ahead and get a pair of dice and just roll it 50 times. Every single time you get a set of doubles, make maybe like a little hash marking here. Let's say you get doubles 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Let's just say that's what it was. Then you'd go ahead and write your probability, or actually, let me rephrase that. You would go ahead and express the frequency. Frequency is how often something happens. And the way we write it, like we said above, was you write down the number of times, in this case the doubles were rolled, because doubles is the thing we were looking for. That's the successful thing we wanted. We wanted doubles. So when you do your experiment, you're going to roll, and how many times you get doubles, that's going to be your numerator. Number of rolls total on the bottom. Well, the instructions already tell you how many times you're going to do it, and they tell you to do it, I believe, 50 times. There we go, right there. Looking for my little arrow. And then you'll write your ratio right here after you do the experiment. If you're working with pairs, take turns. Maybe each of you do 25, and you record it together. It doesn't really matter as long as 50 rolls happens and you record the data. Part 2 over here, compare the ratios in step 1, whatever you get here, to the ratio in step 3, or excuse me, step 1 and 3, so that's this part also that we're doing right now, of activity 1. What do you notice? And explain. There should be some kind of relationship. I am not going to tell you what it is because that's the whole point of this lab, is to experiment and figure it out for yourself. After you've done that question, let's go ahead and move on to number 3 on the bottom. Whoops, let me scroll back down. Number 3, how did your prediction compare to the actual number of times you rolled doubles? Explain any difference. So what you're going to do is you're going to go back up to this first question, and you're going to try to figure out or explain how many times does doubles happen when you make this chart. When you make all of your outcomes, you're going to have doubles in here that only happens a certain number of times. You'll have the number of doubles, oops, let me go ahead and write this down. The number of doubles over the total number of choices. My pen's not writing over here on the side. 1 second. I mean, I can make it work. There you go. Well, it's still not working, so whatever. Number of doubles on top over total outcomes. Well, we can find the total outcomes right now. There's 1, 2, 3, 4, 5, 6, 12, 18, 24, 30, 36. So it's going to be some number out of 36. However many number of doubles that is, you got to figure out based on your chart. When you do that, simplify your fraction. After you simplify your fraction, if you can, then compare that fraction to the fraction of what you get down here when you do the experiment. Because what we're doing now is we're taking the theory. We're taking what we think should happen based on the data given to us, and then we're going to compare that to what happens in the real world when we do an experiment. Because just because this table says there are so many numbers of doubles over here, that doesn't mean that you're going to get all of them, and doesn't mean you can only get them once. You might get them more than one time. So let's go ahead and explore that, and that's what these questions are all asking you to do. Now, after you finish this whole page, go ahead and go to the next page, or the back of this, page 376. On page 376, if I could ever get this to load, which might take us a few moments. So let's go ahead and just take a quick pause while I wait for that. All right, finally my page loaded up, and let's go continue reading the top. There's a lot of vocabulary happening here with some big words, so it's very crucial at this point that you listen carefully, and I'm going to do my best to try to explain this to you. It says, you often use predictions when learning about probability. Quantitative predictions deal with numerical data and measurable data. That means when we say the word quantitative, we're talking about numbers and things you can actually count or measure. While qualitative predictions deal with descriptions, observable data, or non-numerical data. So one deals with numbers, one deals with words, in other words. And here they give us a continuum or a bar, kind of like a rating, where 0 is the likelihood of something happening, which is not at all, to 1, being certain it's going to happen. For example, there is no lottery that I played, so it is impossible for me to win a lottery tonight or tomorrow. Whereas on the other hand over here, I know for a fact that my life will be normal and I will not come into any major money anytime soon because I don't have any money and I don't know anybody with any money, nor do I play lottery. So I am certain that I will not be a millionaire anytime soon, and it is impossible for me to win a lottery if I don't buy any tickets. And then you have other things. And you can think of various things in life that happen that follow on this scale. Maybe going to school tomorrow. Let's say you're feeling sick at school today. So maybe halfway through the day, or maybe you think that, you feel bad, you may or may not come to school tomorrow. Let's say you go home tonight and you're feeling really, really, really bad. So maybe it's more likely that you won't come to school tomorrow. You wake up in the morning and you have a fever, so then you're certain you won't come to school tomorrow. But it might be vice versa for most of us. You might feel kind of sick a little bit right now, but you get a little better after school, you eat, take a nap, whatever. So now it's less likely that you're going to miss school. And then tonight you do your homework. Maybe there's something going on in class, or you're going to a field trip. You don't want to miss that. So now it would be impossible for you to miss school tomorrow because there's no reason why you couldn't be here. Whatever it is, this up here on the top, this stuff, all these words are qualitative data or qualitative descriptions. Qualitative means like how you talk about something or describe something. Qualitative. Down here, this is quantitative. That's numbers you're measuring. There is a 50-50 chance, maybe, of something happening, of rain. Maybe there is a 100% or 1 that school is going to end the first week of June. Maybe there's a 0% chance that school is going to end in, let's say, tomorrow, that there'll be no more school after that ever again for anybody. Whatever it is, you can measure things either with numbers or by using words. That's what qualitative and quantitative mean. And you will be asked to know those two things as you go on through this next activity. So here, now we have all the possible outcomes you get from rolling 2 number cubes. You should have made a chart similar to this on the first page. Only your numbers might run a little differently, but actually no, it should look exactly like this. Shade all of the possible outcomes that have a sum of 9. That means you want to shade all the numbers that when you add them up, you get 9. So let's say, for example, right here, we have 6 and 3. 6 plus 3 is 9, so that's one of them that I would shade. You're going to go through all these lists of numbers and shade all the ones that equal or add up to 9. And then write down how many you have here. Question 4, make a qualitative prediction. Qualitative means you're going to use these kind of words that you see up here. For example, the question that you're being asked is, how likely is it to roll a sum of 9? So let's say you think it'll be certain, likely, maybe it's 50-50, unlikely or impossible. How you decide what word you're going to use depends on what ratio you get when you find all the ones that have 9. So you want to take all the numbers that add to 9 and put that over all of your total choices, which I believe we said the first time was 36. Simplify that fraction and then find which one of these fractions it's closest to on this number line, and then give me the word or the qualitative response that goes with it. That's all you got to do. Step 2, another experiment for you guys. Roll 2 number cubes and record the number of outcomes that have a sum of 9 in the table. So roll some dice, a pair of dice. Every time you guys get numbers that add up to 9, make a little hash mark here, and then make a proportion. It's going to be something over something else, whatever it is. We know we're rolling the dice 50 times, so it should be some number over 50. Because everyone's experiment is going to be different, it would be very rare for 2 groups of people to have the exact same number. Not impossible, though. So if I had to make a qualitative prediction, I would say it is unlikely that 2 groups or more of the same class even will have the same exact data. It's almost impossible, actually, to get that. But, we'll see what happens when I look at these experiments. Now, next, determine the relative frequency of rolling a sum of 9. Use the ratio, and they give it to you right here like we talked about before. Simplify, and just find it. Now, make a quantitative prediction. That means we're using numbers. How many times would you expect to roll a sum of 9 if you rolled both cubes 50 times? Explain. What you want to do is compare how many times does it happen in our chart to how many times did it happen in the experiment. And then see if those 2 things match. How far apart are they? Whatever. Describe it somehow. Because you have to make a quantitative. You're describing. And you're making a prediction. So everyone's data is going to be different. Some people may have, maybe most of their rolls equal 9, whereas others maybe none to hardly any. It just depends on what you got during your experiment. So you can't answer these 2 questions without doing the actual experiment. Number 6, how did your prediction compare to the actual number of times you rolled doubles? Explain any difference. I think that's pretty self-explanatory there. Of course, if you have any questions about what this is really saying, you can ask us during class. After you completed this page, let's go ahead and go on to the next one. And I'll go ahead and move to the top. Up here, we have an investigation. You're going to work with a partner or by yourself, but a partner would be preferable. And the spinner shown is going to be spun 1 time. Determine the probability of each of these events happening. So you got to tell me in a ratio how this is going to happen. Actually, I want the ratio, which is like the fraction. So I want the fraction. I want the decimal and the percent. You need to write that for 7 and for 8 for both of these. All right, just show your work on the page. Go ahead, and after that, let's go ahead and skip 9 and 10. And then let's go ahead and try doing number 11 as your final experiment and record your data there. After you've done that, go ahead and answer questions 12 and 13. I believe after that, let's see, we have a few more questions, but I think I'm only going to limit it to numbers 14 and 15. Whoops, if I can get my pen to work again. There we go. So we're going to answer these questions. This is going to require a lot of discussion with your partner, so hopefully you have a partner. If you don't, feel free to ask the teacher or somebody else who you know knows what they're talking about, hopefully. If you have any questions, ask us in class. Otherwise, good luck with this assignment, and we'll see you later.